Good afternoon. Our team ID is MY369 and the team members are MY369 and Khao Yan Ling. The advisor is Dr. Yung Po and we are from Tunku Abdul Rahman University College. We are from the Faculty of Computer Science. Today, we did a project on precision farming. Precision farming is a concept focusing on observation, measurement, and responses to a variability in crops. For our problem statement. According to a recent study, food demands across the world will increase by 70% by the year 2050. In order to meet the increasing demand, the agriculture sector around the world has to adopt better technologies. Agriculture is an important sector in Malaysia's economy. The agriculture sector contributes roughly 12% of the national GDP, which is the gross domestic product, in Malaysia, and provides employment for 60% of the population. So, as an example, Malaysia is one of the largest seller of flowers, and other well-known products are palm oil. So, another example is that Jackson, who is a 33 years old farmer in Cameron Highland, uses traditional farming methods in the farm. And Jackson feels that it is challenged to maintain the quality of the crops and the quantity of the crops efficiently, as he cannot identify the specific reason that affect the condition of the plants. So in our current solution, farmers have to work hard to observe the condition of the crops, to prevent the spread of disease between plants and to maintain the quality as well as the quantity of the crops. By doing so is really inefficient, I would say, as some of the farmers have quite a big farm and they have to check the plants one by one. They would waste their time on doing the checking and don't have time to do other more important things such as analyzing their plants and what is the optimal solution for the plants. And as we said that traditional farming can also lead to lower efficiency and poor quality of yield due to a slow pace of replanting. For example, palms which brings benefit to people require at least 5 years to grow before it can start producing yields. Yeah, as they are using the traditional farming methods, they may take care of their plants based on experience and not on the facts or the managing variables of the plants. So currently, Malaysia is deploying the Agriculture 4.0 solutions for boosting profit margins as well as reducing risks. There are several themes in Agriculture 4.0 such as process automation and mechanism and indoor farming technologies. The theme that we are going to focus on today is precision farming, which is also known as precision agriculture. Precision farming is a farming management concept based on observing, measuring, and responding to different variables of the crops, such as soil condition, moisture value, fertilizer pH value, to ensure that the practice of farming is accurate. Different information of the crops can be collected with a variety of components, such as sensors, drones, robotics, and autonomous vehicles. By doing so, farmers can know the condition of the plants more easily and allows them to save more time. By doing this solution, the target segment are farmers, farm managers, and farm inspectors. As for the impact, by using this solution, they will save a lot of time for them to take care of their plants. Besides that, they can reduce the number of their workers to observe the plants or to do maintaining on their plants. And this would also reduce the cost of their farm as well as increase the profit margin of the farm and boost their crops quality and quantity. In this project, we are using SAS to analyze and train the dataset. SAS is a command-driven software package which can be used for data visualization and statistical analysis. There are many useful features in SAS, such as highly customizable analysis options, an enormous array of statistical methods and algorithms, especially for advanced statistics, which will bring benefits for users to build models easily. The dataset we use in this experiment is from Kellogg Biological Station. It contains annual crop harvest data of corn, soybeans, and winter wheat from October 2006 to November 2014. The data is collected from the main cropping system experiment based on long-term ecological research. The machine learning algorithms that we use in this project is linear regression and neural network. Linear regression is a statistical test used to determine the extent if there is a linear relationship between dependent variable and one or more independent variable. Linear regression is a low complexity model. It helps to analyze the extent of change in the features that would affect the result. The reason why we choose this method was due to the small size of the data set. This method can analyze the strength of the association between the outcome variable and predictor variables. The model becomes more confident about the underlying relationship and gives robust coefficient estimates for the crops. The next one will be neural network. Neural network is a set of algorithms designed to recognize patterns. Neural network interprets data through clustering input or labeling. The performance of neural network depends on the size of data. This was the reason we choose this method. The small size of dataset makes the training process fast and improves the model performance. So, this is the result and discussion. So, because we are predicting a value, our result will be in average squared error. The lesser the average squared error, the better the algorithm performs. So there's a list that to show the average squared error of different crops. As you can see for soybean, neural network is lower than linear regression. Hence, neural network work better for soybean. And for winter wheat and corn, linear regression has a lower average squared errors. Hence, linear regression perform better. So the advantages of this solution is that it helps the farmer to have better understanding to the crops they planted, as different crops require different environment. But the disadvantages of this solution is that it is not being able to predict crops that are not trained previously. As for the project demo, I will show you the SAS. So this is the EDA of the project. By doing so, we can know which of the features are more important to the result. First, we try it with weed control. As we can see, for winter wheat, weed control shows and winter wheat works better with BAU, which means business as usual. And for the treatment, winter wheat works better with T3 treatments, which is having herbicides to kill the worms so that they won't be bitten. And the T4 would be an organic one without herbicides. So this is the comparison of the features of winter wheats. Winter wheats grow better when they are fertilized with a T3 treatment and in business as usual weed control. As for soybean, we can also see that it is better with fertilized and T3 treatment, which is with herbicide with the basic weed control. But we can also see that soybean is rather good with unfertilizing. Yeah, there's just a slight difference between the result. Lastly would be the corn. It is so obvious that the corn is suitable for fertilized tea tree treatment and the business as usual weed control. Now I will show you the trait model of different crops. So this is the algorithms for soybean, which is neural network and linear regression. It can be seen that neural network performs better. Or for corn, the linear regression performs better than neural network. And for winter wheat, linear regression also performs better than neural network. As a conclusion, this solution is able to help farm workers to maintain the quality of the crops efficiently and is able to identify factors that affect the condition of the plants, such as moisture value, fertilizer pH, soil nutrition, and so on. And for the future recommendation, we would recommend use image processing to determine the conditions of the plants, whether it is worm-bitten, scorched, disease-infected, or healthy. That's it from my presentation. Thank you.